In this example, we have a private equity group that's going to purchase one of these two hotels, okay? And they want to decide what's the best deal. What's going to make the most money for them, right? So we have some data about these hotels. Now it says that the two hotels are similar, although the Regina Inn has 52 rooms and is in a slightly better location than the Merlin Motor Lodge, which has 60 rooms. Okay, 60 rooms. And then we have some information about their occupancy rate and associated relative frequencies or probabilities. Okay, so and we want to, let's see, we're also told down here that the average profit per day for each occupied room for the Regina Inn, it's $40. Okay, for the Merlin Motor Lodge, the average profit per day for each occupied room is $36. Okay, so you're making a little more profit off of the Regina Inn um, on a per room basis, right? So, um, and so we want to figure out, okay, what is the best deal here? So let's first of all, I guess we'll start with part A. It says find the average number of rooms occupied per day at each hotel. Average number of rooms occupied each day. So essentially, it says average, but we're given probability data. And like I just said in the last example, the expected value is the same as the average. So let's calculate the expected value. Okay. So we're going to let the random variable x be the occupancy rate, of the Regina Inn. The occupancy rate of the Regina Inn. Okay. And then we can calculate the expected value of that random variable by just taking all the outcomes and multiplying by their associated probabilities. Okay, so the occupancy rate of 80%. So 80% of the rooms are occupied 19% of the time. 0.19, sorry, 19% of the time. Okay. 85% of the rooms, the occupancy rate of 85% occurs 22% of the time. Okay. A 90%, oops, hang on, 90%, 0.90 occupancy rate happens 31% of the time. 31, so 0.31. And then a 95%, 0.95 occurs 0.23, so 23% of the time. And we have 100% occupancy only 5% of the time, 0.5. All right, so that'll give us our expected value. If I stick that in my calculator, I get 0.8865. Okay. So now that is the expected occupancy rate. Okay. So that's saying on average, 88.65% of the rooms are occupied at any given time on average. Now there are 52 rooms, right? So that tells us that 0.8865, which is 88.65%, times 52 gives us 46.1 rooms per day. Okay, so that's the average occupancy for the Regina Inn, is that 46.1 rooms are occupied at any given time on average. So rooms per day. All right, so let's take a look at the other one, the Merlin Motor Lodge. So now I'm going to use a different random variable. I'm going to call it capital Y. And I'm going to say, let's let that be the occupancy rate for the Merlin Motor Lodge. The occupancy rate of Merlin Motor Lodge. Okay. Oops, lodge. I gotta spell lodge, right? Lodge. Okay. So let's find the expected value of that. So if we look at the Merlin Motor Lodge, it looks like 75% of the rooms are occupied 35% of the time. And then 80% are occupied 21% of the time. And 0.85% of the rooms are occupied 18% of the time. 90% of the rooms are occupied 0.15, 15% of the time. Let's come down here. We got 95% of the rooms are occupied 9% of the time. And then we have 100% of the rooms occupied 2% of the time, 0.02. All right, so now we can find the expected, let me just put it over here, the expected value of the occupancy rate. And if I put that in my calculator, I get 0.8240. All right, so now but we're asked to find the average number of rooms occupied. And this motel has how many rooms? 60 rooms, right? If you go back up to the problem statement, you can see the Merlin Motor Lodge has 60 rooms. And it looks like on average, 82.4% of the rooms are occupied. So if we take that 0.8240 times the 60 rooms, then we have 49.4 rooms on average, rooms per day. Okay, so that answers that part of the question. Now the investor has to make a decision based on this. So we have to compare what, how much expected daily profit. We're going to compare the expected daily profit of the two motels. And to do that, we're going to use the information that we're given up here about how much profit you get for each occupied room. So for the Regina Inn, each occupied room gives a profit of $40 per day. And for Merlin, it's $36 per day. All right, so we're making a little more on the Regina per room. Okay, but we got a lower occupancy rate for Regina. So let's calculate these things. So let's do the Regina Inn. So for Regina, on average, 46.1 rooms are occupied each day. Okay, and then our profit, we're going to multiply that times $40. $40 per room per day, right? So our expected daily profit from the Regina would be $1,844. Okay. Now for the Merlin, for Merlin, we have an average of 49.4 rooms per day occupied. Rooms per day. And we're going to multiply by $36. $36 per room per day. All right, so that gives us a total of $1,778 profit. So just comparing those two, you can see that the Regina Inn has an advantage, that it's going to make more money, makes us a little more money. So if we had to decide between these two hotels, I would say we'd probably want to buy the Regina. It's going to make us more money, right? So the Regina Inn has a higher expected profit. Has a higher expected profit. Okay, so assuming that profit is our motive, then we should buy the Regina. Alrighty, so I will meet you for the next example.